Illustrative examples. Consider the pairs of angles whose measures are given below and find out which of them are coterminal. 420 degrees and 60 degrees. 420 degrees minus 60 degrees is equal to 360 degrees. Therefore, the given angles are coterminal angles. 750 degrees and 30 degrees. We know 750 degrees minus 30 degrees is equal to 720 is equal to 2 multiplied by 360 degrees, which is a multiple of 360 degrees. Therefore, the given angles are coterminal. Perpendicularity. The two lines are said to be perpendicular to each other when a right angle is formed at the point of intersection of the two lines. Line AB and line CD are perpendicular to each other at the point O. This is written as line AB perpendicular to line CD. Perpendicularity of segments and rays. Two rays or two segments or a ray and a segment are said to be perpendicular to each other if the lines containing them are perpendicular. In A, ray OA is perpendicular to ray OD. In B, segment AB is perpendicular to segment CD. In C, line AB is perpendicular to ray OD. In each case, measure angle AOD is equal to 90 degrees. If line OA is perpendicular to line CD at the point of intersection O as in the given figure, then the point O is called the foot of the perpendicular drawn from point A on the line CD. Congruent angles. If the measures of two angles are equal, then the angles are called congruent angles. Measure angle ABC is equal to measure angle PQR is equal to 30 degrees. Angle ABC and angle PQR are congruent, and we write it as angle ABC is congruent to angle PQR. Properties of congruent angles. Reflexivity. Angle ABC is congruent to angle ABC, that is, every angle is congruent to itself. Symmetry. If angle ABC is congruent to angle PQR, then angle PQR is also congruent to angle ABC. Transitivity. If angle ABC is congruent to angle PQR and angle PQR is congruent to angle XYZ, then angle ABC is congruent to angle XYZ. Inequality of angles. If measure of one of the angles is greater than that of the other, then the angle with the greater measure is said to be greater than the angle with smaller measure. Measure angle ABC is equal to x degrees, measure angle PQR is equal to y degrees, and if x is greater than y, then angle ABC is greater than angle PQR. The measure of a given angle is 5 times that of its complementary angle. Find the measure of the given angle. Solution. Let the measure of the complementary angle of given angle be x degrees. The measure of the given angle will be 5x degrees. According to the definition of complementary angles, x degrees plus 5x degrees is equal to 90 degrees. Therefore, 6x degrees is equal to 90 degrees. Therefore, x degrees is equal to 15 degrees. The measure of the given angle is equal to 5x degrees is equal to 5 multiplied by 15 is equal to 75 degrees. Geometric sentences and their proofs. If-then form of statements. A geometric property is often expressed in a sentence containing the phrase if-then. Any statement stated in the if-then form is said to be a conditional statement. In a conditional statement, there are in fact two statements connected by a phrase if-then. The part of if-then form of statement which follows if is called antecedent and that which follows then is called a consequent. For example, if two distinct points are given, then one and only one line is determined. Broadly speaking, if P, then Q. From F to P, it is antecedent. Data given sufficient for consequent. And from then to Q, it is consequent. That is to be proved necessary for antecedent. To fulfill the property given in consequent, the condition given in antecedent is sufficient. To make the condition given in antecedent applicable, the property given in consequent is necessary. For example, general statement: two intersecting lines are contained in one plane. Conditional statement: if two lines intersect each other, then they are contained in one plane. Converse statement: a statement obtained by interchanging antecedent and the consequence is called the converse of the original statement. For example, general statement: if two lines are coplanar, then either they intersect or they are parallel. Converse: if two lines either intersect or are parallel, then they are coplanar. If a property is true, it is not necessary that its converse must be true. For example, statement: angles forming a linear pair are supplementary. Converse: supplementary angles form a linear pair. False. Axiom, theorem, corollary, and proof. The terms or statements whose proofs are not to be asked are called axioms. The statements that we prove from axioms are called theorems. The process of establishing the conclusion by logical reasoning on the basis of axioms and previously proved theorems is called proof. Any property can be written in the form of when, then. From antecedent, if we reach up to the consequent using axioms or previously proved theorems, then it is a direct proof. When we deny what is given in the consequent and proceed logically and arrive at a step which either contradicts what is given or some well-known fact, then we agree that the consequent is true. Conclusion regarding the truth of the consequent is thus reached indirectly. This method of reaching the conclusion is known as indirect proof. Illustration of indirect proof. Theorem: two distinct intersecting lines intersect in only one point. Given: let two distinct non-parallel lines L and M. To prove: the intersection of line L and line M is only one point A. Proof: suppose line L and M do not intersect in only one point A. If possible, line L and M intersect in point B also. As points A and B belong to line L, therefore line AB is equal to line L. Similarly, line AB is a line M also. Here we get line L and line M are the same, but we assume that they are distinct lines. This is absurd, so our assumption is wrong. Therefore, two distinct intersecting lines intersect in only one point. Corollary. A property that can be readily derived from a theorem is called corollary. Theorem: if two lines intersect each other, then vertically opposite angles are congruent. Given: line AB and line CD intersect each other in point O. To prove: angle AOC is congruent to angle BOD. Angle AOD is congruent to angle BOC. Proof: line AB and line CD intersect in point O. Measure angle AOC plus measure angle BOC is equal to 180 degrees. Equation number 1. Angles in a linear pair. Measure angle BOC plus measure angle BOD is equal to 180 degrees. Equation number 2. Angles in a linear pair. Measure angle AOC plus measure angle BOC is equal to measure angle BOC plus measure angle BOD from equation 1 and 2. Therefore, measure angle AOC is equal to measure angle BOD. Therefore, angle AOC is congruent to angle BOD. Similarly, it can be proved that angle AOD is congruent to angle BOC. Therefore, if two lines intersect each other, then vertically opposite angles are congruent.